In this video, I will explain how to do correlation and regression analysis using Microsoft Excel. Correlation is a statistical technique used to measure and describe the strength and direction of relationship between two variables. Correlation coefficient can range from -1 to +1. -1 indicates that as one variable increases, the other decreases, and +1 indicates one variable increases, the other one also increases, and 0 indicates no correlation. Here's an example. Here we have data about interest rate and median home prices. We know there is a correlation between interest rate and median home prices. We know it's very intuitive. As interest rate increase, home prices tend to fall. But we want to quantify this relationship, and for that purpose we'll be using correlation analysis. I'll be using this command, which is called as correl, and then select one variable, which is interest rate, and then comma, and then other variable, hit enter. That gives us -62%. Negative indicates that when interest rate go up, median home prices will go down. The next topic is the regression analysis. Regression analysis is used when we have one dependent variable and multiple independent variables. It's a statistical method used to examine the relationship between one or more independent variables and a dependent variable. Dependent variable is also called as a response variable, and independent variables are also called as predictors. The purpose of regression analysis is to understand how the dependent variable changes as the independent variables vary. An independent variable is the one that is changed in an experiment to observe how it affects the dependent variable. And the dependent variable is the one that's being measured or observed in an experiment. It is expected to change in response to changes in the independent variable. When doing a regression analysis, we'll be using these terms, intercept and slope. Intercept is the value of y when x is 0. This is x and this is y. Here the value of x is 0 and the value of y is 20, so that will be intercept. Slope is an indication of rate of change in y variable with the change in independent variable. So if you move here 1 degree, how much change happens in y degree? That's called as slope. In this example, we want to determine number of weekly riders. We have a number of independent variables which are represented by x1, x2, 3 and 4, and then there is a dependent variable which is number of weekly riders. Now independent variables are price per week, population of city, monthly income of riders, and average parking rate. And these independent variables determine number of weekly riders in a city. So we want to make a model for prediction. Therefore, we will be doing a regression analysis. And for this purpose, click on data and then data analysis and then regression. Click OK. First one is y range. Y variable in this case is number of weekly riders. So I'm gonna select this whole column and then input x range. All x variables we are gonna include here. Then it says label because I did not select labels, so therefore I will not check it. And output range, I want my results to appear here. Click on OK. In this regression result, there's a lot of information, but the key information is highlighted. So the first thing is adjusted R-square. This adjusted R-square indicates the strength of relationship. This value is very high, that's 93.5%. So which means it's a good model. There is a strong relationship between dependent and independent variables. Furthermore, a high value indicates that a large proportion of the variability in the dependent variable can be explained by the independent variables. This is a general equation for regression whereby y is dependent variable, beta naught, which is intercept, plus beta 1, that's slope or coefficient, and x1 is first independent variable, plus beta 2, which is the slope coefficient of second variable, x2 is second variable, and the last one is error term. And this is our equation. This is the forecast for dependent variable, and the first one will be intercept, and here is our intercept, 100,222 minus the slope coefficient of the first variable is -689.5 minus 600 689.5, and the name of this first variable is price per week. Slope coefficient of second variable, which is 0.0549, and the name of the second variable is population of the city. The slope coefficient of the third variable is -1.3, and the name of the variable is monthly income. So here it goes. And the slope coefficient of the last variable is 152, and the name of the variable is average parking rate. Now whenever you want to do forecasting or you want to make a prediction, you will just enter values in this equation. So for example, you can enter here monthly income or population of city. This model will give you forecast for dependent variable accordingly.